Welcome to the Barawan branch. I scratch-built this bridge, board by board, for my neighbor's layout. Join me as I outline the process. Let's begin with an overview of the specifications. The bridge span is 565 mm. It crosses a river valley and a light road partway up the slope on one side. The bridge has a ballasted deck and is constructed of scale lumber. Now let's look at the components of a New South Wales Railways ballasted deck trestle. Starting at the top are the ballast retainers. They sit on the deck timbers which are supported by stringers. The upper set of stringers are supported by evenly spaced transoms. A second set of stringers support the transoms. And those lower stringers sit on corbels that are fastened to the bents. Looking from underneath, we can see the relationship between the components. Each row of stringers sits directly above one of the vertical bent poles. The inner two rows of stringers are directly under the track rails. The project required a basic set of tools. All the scale lumber was stained with India ink and isopropanol before cutting it to length. The deck is the key element of any bridge. Its top surface needs to be flat and square. To achieve this, I glued the deck timbers together over a plan of the bridge drawn on a piece of high-density foam. It was covered with clear packing tape to prevent glue adhering the deck to the foam. I used a meter rule and drawing squares to keep the deck timbers square to the track center line. The fixed square kept the entire assembly in place, while the loose square helped push successive timbers firmly and squarely against the growing deck. I stopped laying timbers at regular intervals to allow the glue to dry. A weight was laid over the drying section to keep the timbers flat on the foam. The first set of stringers was then glued to the deck. I cut each length of stringer so that it joined its neighbor above a bent. A length of steel bar held the stringer vertical and straight while the glue set. The stringers were lightly sanded to provide an even surface for the transoms. The transoms are of two widths. The wider timbers align vertically with the bents, while the narrower timbers are evenly spaced between the wider timbers. I first glued the wider timbers in place. Here I'm centering and squaring the transom across the stringers. Then I recheck that the distance between the two transoms matches that for the bents. The gap between narrow transoms is 4.8 mm, which conveniently is the width of a piece of channel section styrene that I had to hand. I cut two pieces slightly longer than a transom. Each piece was placed against a pair of wide transoms. I then glued narrow transoms against the pieces of channel. Once the glue had bonded, I placed the pieces of channel on the other side of each narrow transom. I then glued 2 more transoms against the pieces of channel. I repeated the process until all the transoms were in place. Working in this way produces a neat finish. The transoms were lightly sanded before fitting the next set of stringers. The second row of stringers were attached in the same way as the first, making sure that their joints did not align with those on the first row. This maximizes the strength and rigidity of the bridge. The surfaces were sanded as before. The corbels over the middle 2 bents on the prototype are short, whereas a continuous length of corbel timber runs from the embankment to the outer bents. That long length of timber is supported near the bridge end by piers that are just above the ground. I began by gluing the 4 long corbels at one end and worked onwards to the other end. I used small sprung clips to hold each corbel in place until the glue bonded. I like these little clips. The faces make good contact over their full length and the spring is quite strong. To prevent the clip handles from interfering with each other, I glued the first and third corbels of each set until the glue bonded, and then the second and fourth corbels. The surfaces were lightly sanded. I drilled holes for each nut, bolt and washer casting. It's amazing how quickly the total grew. Let's look at a prototype bent for a moment. The headstock sits atop the poles. Note the strapping between the headstock and each pole. The bents sit above the ground on concrete footings. A pair of timber sills are bolted to the poles just above the footings. They are just visible through the grass on the second bent in this photo. Diagonal bracing is bolted to each pole and the end of each headstock. The model poles are 4 mm diameter dowel. The headstocks, sills and bracing are scale lumber. NBW castings and strapping were added. The end piers consist of just a headstock glued to short sections of dowel. I spread spac filler over 5 by 6 mm timber to represent the concrete footings for the bents. The following day they were lightly sanded before being stained with aged concrete acrylics. The bents were glued to the footings with full-strength PVA. Full-strength PVA was also used to glue the bents to the deck. I began with the center bets and worked towards each end. That way I could get tools and supports in without disturbing previous work. I used a block to set the position for the headstock, then used a square to get the bent vertical. I checked that the poles were in line with the stringers. A length of 3 mm metal strip was inserted between the inner stringers to provide additional support to the deck. This bridge doesn't have visible abutments. Instead, each end eases into the embankment just beyond nearly buried end piers. However, the embankment is supported with retaining walls near to the first bents at each end. The walls comprise a vertical section directly under the bridge and angled wing walls, each of differing lengths and slopes. Being constructed of heavy planks, they are easily reproduced in model form. I made the center section 8 planks high. A square held the assembly in place as each plank was glued on. For the wing walls, I began by gluing 9 planks together. The overall length was greater than needed. I then glued planks across the assembly at 6 to 8 scale foot intervals. When the glue had dried, I cut the assembly diagonally so that each piece was 8 planks high at one end and 1 plank high at the other. I repeated this process for another pair of wings, being sure to cut them on the opposite diagonal. I then trimmed each diagonal to the anticipated length for the setting. Better to have too much than too little. The wings were subsequently shortened as scenic development progressed on the layout. Here's the bridge in place on the layout. Foam pieces support the end piers, bents and retaining walls. The scenic shell will be laid over these.